Hey everybody, Jeff Oriema here. When you ask an agent to create a Jira ticket, and a few seconds later the ticket exists, we usually say that the model called a tool to make that happen. That's useful shorthand, and it's technically correct, but it can also make the process sound more straightforward than it really is. The model probably didn't connect to Jira. It didn't authenticate with Jira. It didn't send an HTTP request. Most likely, it generated a structured request asking the harness, that is, the application around it, to do those things. So, I want to walk through what actually happens during an MCP tool call. Let's use a simple example prompt. Create a Jira ticket for the login bug we just discussed. The first thing the harness has to do is build a request for the model. That request includes the user's message, whatever conversation history the model needs to understand, quote, the login bug, any relevant system instructions, and descriptions of the tools that are available. A Jira tool might be described with a name like create Jira ticket, a short explanation of what it does and a schema for its arguments. Maybe it accepts a title, a description, and a project key. Usually there isn't a separate search step here. The conversation and the available tool definitions are included together in the inference request, and the model chooses among those tools based on their names, descriptions, and schemas. It's good at that. Those definitions may be cached to reduce cost or latency, but logically they are still part of the model's context. The model doesn't need the Jira implementation. It doesn't need an API client, credentials, retry logic, or any of the other code that actually creates the ticket at runtime. It only needs to know that this capability exists and what a valid request for it looks like. Remember, models are next token predictors, and that's their bread and butter. The model is then invoked with all that information. It's like a function call or RPC if you like. During inference, it decides that the Jira tool is appropriate and produces a tool use response. Conceptually, that response might look something like this. Depending on the model API, the arguments may be constrained to the tool's schema while they're being generated. That means the model can be prevented from omitting required arguments, using the wrong types, or producing malformed JSON. But that only tells us that the request has the correct shape. It does not tell us that WEB is a real Jira project. It does not tell us that the current user has permission to create a ticket there. And it definitely doesn't let us know whether the application should allow the operation. Those decisions are still in the application's services, not in the model. At this point, the model has not created anything. It produced a structured request indicating which action it wants the application to take. The harness receives that request and decides whether to execute it. It might check the user's permissions, it might apply an organizational policy, it might ask for human confirmation, for example, or it might reject the request entirely. This distinction matters because a model being able to request an action is not the same as a model having authority to perform it. If the request is allowed, the harness invokes the actual tool implementation. And this part then gets into the realm of just ordinary software. Some code authenticates with Jira, constructs an API request, it handles network failures, rate limits, retries, logging, and whatever else the integration requires. The model generally doesn't know or care whether the tool is implemented as a local function, an HTTP call, a shell command, an MCP server, or something else entirely. Once the ticket has been created, Jira returns a result. Maybe it looks something like this. That result is returned to the harness, but the interaction still has a few more steps ahead. The tool usually does not formulate the final response to the user. It returns data. The harness then puts that result back into the model's context and invokes the model again. The model can now see that the request succeeded and that the new ticket is WEB1427. It uses that information to produce the response the user actually sees. So, what looked like one interaction was probably at least two model invocations. The first inference selected a tool and generated its arguments. The application executed the tool. The second inference interpreted the result and generated a response. And the loop can continue The model might search Jira for duplicate tickets first. Then it might look up the correct project. It might create the ticket maybe after all of that is done. Each of those can be separate tool requests followed by another inference. This is also where MCP fits in. MCP does not fundamentally change this loop. It standardizes how the application discovers tools, reads their descriptions, invokes them, and receives the results. The model still chooses the capability during inference. The harness still mediates the request. Some external implementation still performs the operation itself, and the result still has to come back to the model's context before the model can do anything with it. Remember, they're next token predictors only. So they're doing things with these JSON responses that are entirely within that capability. So when we say that AI called tool, what usually happened is a little more specific. The application told the model which tools were available. The model generated a structured request. The harness decided whether to allow it. Normal application code performed the operation. The result was added to context, and then the model was invoked again to respond to the user. If you heard any unfamiliar terms here, maybe inference or harness, I made a video a couple weeks ago that defines and explains some commonly used but underdefined AI terms. I'll link to it in the description. To the MCP experts viewing, what did I miss? MCP newbies, was this helpful? Drop me a comment, let me know. That's it for now. See you next time.